Okay, so the next thing is we are going to have now only one certain issue here, that is we can't plug out R1 and R2 each time and put in different values. That is too uneasy and we are too lazy people. So if you want to divide, if you want to be able to control, okay, let's say v1. So in this setup, v1 would be, so we learned that v1 over v2 would be equal to r1 over r2. So we won't be able to, like, if we have to plug each time a different resistor value to change the ratio, that is quite difficult, and we can't get any desired v1 value. Only depending on the value of the resistors available, we can have the value of v1 and v2. If you want to continuously change v1 within a certain range, if you want to vary it continuously, then we need a variable resistor. Now, if you can create a setup where the midpoint, like this midpoint can slide over a resistive material, then the resistance would change according to the contact point of the slider, right? So if you have a potential difference, and that potential difference is falling across this entire resistor, but I want to take only part of it outside. So I keep my slider, the sliding key, here. So if this is A then and B, then this point where the slider is C, right? Now this would be my V out. Okay, and let's say that the terminal potential difference of the battery is V, then V out would be equal to R1 over R1 plus R2 times the terminal potential difference. What is R1? The resistance of AC is R1. The resistance of the part BC is R2. And we know that V1 over V naught over the remaining potential. Let's call this potential V naught dash. So V naught over V naught dash would be equal to the same ratio as R1 AC over R2. This is like V1 V2. V naught dash would be in the same ratio as the resistors AC BC. Okay, now from that, if you want to, but we also have the equation V is equal to V naught plus V naught dash. So the entire terminal potential is the summation of the individual ones, and you can substitute for V naught dash in terms of V naught from this equation. V naught dash would be R2 over R1 times V naught. So if you bring that here and substitute, V would be equal to V naught plus R2 over R1 times V naught, and if you take the V naught common, if you take the V naught common, what you will have is V equals V naught taken common would have 1 plus R2 over R1. That would be just 1 minute. Yeah, that would be V equals V naught times R1 plus R2 over R1, and if you change the subject, V out would be R1 plus R2 into the terminal potential difference, the entire potential of the battery. Okay, now this R1 and R2 depends on the positions of C. R1 is AC's resistance, the resistance of the part AC, and the resistance of the part BC, R2. Now if I can change it, if I can change the position of this somewhere here, then the resistance of AC would change, that is R1 would change. Yeah, the summation of them would remain the same. R1 plus R2 would remain the same, but by changing the length of AC, I will be able to continuously change the output voltage I need. So I have a certain potential, and from that potential I am dividing that potential across AC and CB. Since the resistor is variable, that you can continuously change the values by sliding the key, you can continuously change this output potential as well. So a potential divider in which the potential can be varied continuously is called a potentiometer. Okay, a potential divider in which the potential can be varied continuously is called a potentiometer, and it is shown here. So this is how a real one looks like. Now note down the three terminals here. So it's the A, B and C. So A, B and C, there are three terminals.